Hello everyone, my name is Aditya Shah and I'm presenting for the final project. My group members are Aryan, Jomar, and Rehan. So the data set that we picked for this final project is flight price prediction. So the data set consists of data from the website Ease My Trip with flight booking options for India's top 6 metro cities from February 11 to March 31st, 2022. It provides flight options that a user could book with features to categorize the data such as the airline, flight code, source and departure cities and times, amount of stops, seat class, total flight time, the number of days booked before the trip, and the price of the flight. There are a total of 300,261 instances and 11 features in the dataset. Now, looking at the big picture about supervised learning, the dataset consists training examples that are labeled airline, flight, city, class, etc. As for the regression task, the goal is to predict flight prices which are numerical values and in Indian rupees. And for the batch learning, dataset contains examples from February 11 to March 31st, 2022. The dataset is not receiving any new data, and so adjusting for it is unnecessary. So the overall task is to use predictions to inform the user when prices are the cheapest for any given flight.
We are now going to go over the features in EDA for this dataset. The dataset has 3 numerical features and 9 categorical features. Numerical features are the price of a ticket in Indian rupees, the amount of days you can buy a ticket in advance, and the duration of the flight measured in hours. For categorical features, we have airline companies, the flight code, the departure and arrival cities, the time of departure and arrival, the number of stops per flight, and the type of class the flight is. With these, we can make some visual data. This graph shows a comparison of the price of a ticket by its class and airline. For economy, Air Asia on average has the cheapest flights and Vistara has the most expensive. Vistara and Air India are the only airlines with business class and they are significantly more expensive than economy, with Vistara being the more costly one out of the two. This next one shows a comparison between the price of a flight with the number of stops it has. Direct flights on average are the cheapest and the flights with one stop cost the most. This graph shows a comparison between the price of a flight with the amount of days left to purchase a ticket. Flights are cheapest when they are booked 20 or more days in advance. The value of a flight starts to hike after there are less than 20 days left and the value peaks around the very last day. For the histograms, the top left one shows that the most common duration for a flight is around 10 hours. The top right one shows that most flights have 10 to 15 days left to buy a ticket. The bottom left graph groups the number of flight tickets by their price. The most common price seems to be around 10,000 Indian rupees, which is around 162 Canadian dollars, with over 190,000 flight tickets costing that much. Using the correlation coefficient, there is a slight correlation between duration and price, meaning that they both increase together. The negative correlation between price and days left could indicate that prices increasing implies days left decreasing as shown on the graph. With these observations, we can assume that to secure the most affordable flight, choose Air Asia in economy class on a direct flight, ideally purchased more than 20 days in advance.
I'm going to walk through the pre-processing pipeline and the models that were used to train our dataset. For starters, we split our data into numerical and categorical data as usual. For the numerical values specifically, we used min-max scalar since our data didn't really follow a Gaussian distribution. And for categorical data, we opted for ordinal encoder, which converted categories such as economy or business into their numerical values, simplifying the information so that our model could process it. These pipelines are then joined using column transformer, applying the transformations to every column in our dataset. With all of this done, the data is transformed into something more easily analyzed by the models I'm going to talk about in a second. We then split our data into an 80% training set and a 20% testing set, which basically means 80% of the data was used in training and 20% so on. That training set was then used in 3 different models to predict results similar to those in the test data set. Each of these will be tested against the evaluation metrics to determine which one is the best. The first model we used was the linear regression model. This is a simpler yet one of the more effective models for numerical data. It assumes a linear relationship between the features and the target variable, making a good starting point. Next, we brought in ElasticNet, which combines the regularization properties of lasso and ridge regression, preventing overfitting while allowing for feature selection. Then at the very end, we used Random Forest Regressor. This model used multiple decision trees to make its predictions. We trained each model on their dataset, but for this one specifically, we had to tweak max depth to make sure there was no overfitting. And once all models had been trained and tested, we pulled their metrics to see which one was the most efficient.
Now I'll go over the last part of our presentation, our evaluations of our models, the findings of our best model, the limitations we've come across, and next steps we could take to improve our model. Here are the metrics to evaluate our three models. The table provides us with the correlation coefficient and the error. We can clearly see that ElasticNet performed the worst out of all of them, having the highest errors and the lowest correlation coefficient of 0.5. The second best would be linear regression, and Random Forest is our best, having the lowest errors and the highest correlation coefficient of 0.96. Now here's our findings. This is a graph comparing the actual price and the predicted price given by our model. In the middle of the graph, we can see that many of the prices are either overestimated or underestimated. There also seems to be a weird flat line in the 40,000 to 80,000 Indian rupees range, with it not predicting any of the actual very high prices in the top right corner. Here's another graph, comparing against the other two numerical values in our dataset, the days left and the duration. We can see that in both graphs, there are some underestimations, such as in the days left graph at the very beginning, or in the right of the duration graph. There is also overestimation, and our model seems to almost perfectly match the duration graph. Here's also a graph of our learning curve. We can see that the error is high, and also that the two lines almost converge. This gap pretty much means that there is high variance or overfitting. We also almost got the lines to converge by lowering the hyperparameter of the max depth. Now we came across a few limitations during our project. The first being our large dataset. Attempting to graph or train our model on some algorithms would take extremely long, sometimes 20 minutes to complete or never ending. And so our next steps for the future. There is a lot more room for fine-tuning, such as trying to use grid search or randomized search to find more better hyperparameters for Random Forest, as we only tried one of the hyperparameters, which gave us more accuracy, but at the cost of a larger error. There was also the option of cleaning our dataset, like removing the flight number column to reduce complexity, and also a bit of outliers that had random spikes in prices that we could have removed because they are unpredictable. And that is all for our presentation.